Assalamualaikum and hi, we are from Group 6 Section 7. We will present about equilibrium of forces. So I would like to introduce my group members. Look at this forces board, which you might have in your school. At the top, we have these two pulley wheels. This spins freely. This is important because they must roll when the string moves even slightly. Here are the strings. They go over the pulleys and this weight hang on at the end. We know what the weights are. This one at the left is 3 Newton, this one in the middle 4 Newton, and on the right is 2 Newton. So we know what the forces on string are. We have a knot yet in the middle. This represents as a small body or object. Imagine this matchbox is the object. If the string were tied to the matchbox, it would be as though the string were tied together at one point. Then we can ignore the matchbox and just concentrate on the string that pull on each other. In other lessons, you have heard about free body diagram. Well, this knot is a free body. It will go wherever the forces move it. Looks at this sheet of paper that I have taken on a board, so that I will draw the position of the string on it. Later, I will take a paper off and the pencil marks will be the data we would give.
So let's look closely at the acting force at this point right here. The mass on the string has 3 Newton weight on it. The pulley in the string has the tension on the string. The tension is same all the way down on the string and all the way to knot. Here, and the string on the right, the tension is 2 Newton all the way. And the forces on the middle string is 4 Newton. This 4 Newton act vertically downwards towards the center of the earth. These two forces on the sides are not pulling directly upwards, but they are able to balance the vertical downwards forces. Let's call these forces F1, F2, and F3. We want to record on the paper. Now I will check once more the center in the position that the forces have moved due to. The strings and the weights must not rub against the board because we don't want any other forces like friction to come in here and confuse the picture. Now I will press the knot against the paper and mark its position. And I will also mark other 3 positions with the edges of the paper. Now I have dots to join and I will be able to join the direction of the string.
Now, let's take the paper off and use the ruler to mark the line where the strings were. Like that. And now, we can redraw on the board. Now, we have the directions of the forces. What about the magnitude? Remember that the vectors have the magnitude and direction. F1 equal to 3 Newton, so we use a length of 4 cm represent 1 Newton. So, force vector F1 is a vector of 12 cm long because the force is 3 Newton. Force vector F2 is a vector of 8 cm long because the force is 2 Newton. And finally, will be a vector of 16 cm long because the force is 4 Newton. You must remember that these vectors are not the picture of the strings. They are arrows that show magnitude and direction of the forces in the string. There is one vector you must to draw. It's the resultant force of vector F1 and F2. We can't see yet, but it must be there because the notch did not fall down. There was a force to hold it up, motionless. That force was the resultant force of F2 and F1. It have to be the same as vector F3 but opposite direction.
Remember, the knot was not moving. That tells us that the downward force was exactly balanced by an upward force. So if we add the downward and outward vectors, the sum of the vectors is 0. I've copied the downward force vector F3 and I paste it over the resultant force, like this. I'm adding these two vectors together. They are equal in length and opposite in direction, so the sum of the two vectors is 0. This upward resultant vector is the result we get when we add vectors F1 and F2. How do we add them? Here is F2. We can move vector F1 parallel to itself. We do not change its magnitude or direction, so it's okay to move it parallel to itself. And look, if we add F1 to F2 using head-to-tail method, we get the resultant R. We get a closed figure, a triangle. Now we can check our addition of vectors in another way. Here are the three vectors again. If we take F1 and move it down here and move F2, our longest line of version, keeping its direction the same, we end up with this triangle. The triangle is formed by the three vectors placed head to tail.
The triangle is a closed figure again. We have added all the vectors and the result is 0 force. We know it's 0 because nothing is moving. There is a useful robot said, if a number of forces are in equilibrium so that nothing in the structure is moving, then the vector can be arranged head to tail to form a closed polygon. A polygon is a many-sided figure. A triangle is a polygon. A four-sided figure is a polygon, and so on.